Once again, welcome to All This Math. This is Professor Parker, and today we are talking about graphing trig functions. And these problems were sent in by my little cousin Elijah down in Baltimore. Shout out to him. Thanks for sending these in, bro. So, number one, y equals 4 times sine of theta. Number two, y equals 1/2 times sine of theta. And number three, y equals 3 times the cosine of theta. These are like some of the more fundamental trig functions that we're going to graph. We're just going to do some kind of like quick and dirty graphs. These problems aren't too involved, but it's just like an introduction to how to graph trig functions. They do get much more complex than this, but today we're going to start off with some fundamentals. So, some things that you want to consider when you are graphing trig functions. There are different parts to this equation, right? There's something called the amplitude, which basically tells you how high the graph will go and how low the graph will go. Because it's going to be a wave, right? It's going to be a wave, right? You know, just like in a pool or on a river or a lake or in the ocean, on the beach, it's going to be a wave. That's what this graph is going to look like. But the question is, how high is the wave going to be? Or how low is the wave going to be? That's the amplitude. Now, where do you get the amplitude from? It is this number right here, right? That's always the amplitude, the number that's in front of the trig function or the trig ratio. Sine, in this case sine, in this case sine, in this case cosine. All right. Now, something else. There's another value, and amplitude is represented by the variable a. But what I should do is give you the general form for the trig functions. Let me write that down for you, because we're talking about basically y equals a times the sine of bx plus c plus d. Now, this general equation is much more complex than these problems, and that's fine. All that means is that we're not going to have to use all of these. We don't have all these variables. Like, we don't have a c, right? Because there's no parentheses drawn, because we only have this theta, which is just the angle in radians, all right? And we also don't have a d, right? Because that represents a vertical shift, right? That means the original graph, or as we say, like the parent function, right? The general function will be shifted up that many units or down that many units, okay? So we don't have, in this number one right here, we don't have C, we don't have D, we have B. B is just the coefficient of theta. So in this case, we would say B is 1, because if there's no number written in front of theta, right, then it's understood to be 1, all right? Now, A is, or could be considered as the coefficient of the trig ratio, in this case 4, and that's the amplitude. So we're going to say A is 4. Now, what is B used for? B is used to find something that we call the period of the trig function, all right? The period is like how wide is one cycle, all right? So we got numbers inside of the function to tell us how high the function goes, and we got numbers inside of the function to tell us how wide it'll be, all right? So this is the formula to find the period. We say capital P, which stands for period, is 2 pi divided by B. Now, 2 pi, of course, is in radians. B is the value that's in front of theta. So in this case, it's 1. So we're doing 2 pi divided by 1, which is equal to 2 pi, right? Now that's going to be significant when I draw the graph. Just like this 4 is going to be significant when I draw the graph, all right? So like I said, in this particular problem, C is 0 and D is 0. So we can just get the graphing now. So I'm going to draw like a quick and dirty graph down here. And I'm only going to show like the positive, or the first quadrant. So we got our y-axis, label that. We got our x-axis, label that. I'm going to draw 4 spaces, right? it's customary if we're doing like a fundamental, a rudimentary graph, we just do 4 spaces. So I'm gonna start out here. And that's gonna be my period. My period is 2 pi, right? Because what that means basically is 1 full cycle goes 2 pi radians, that many radians. Then I'm gonna cut this in half, right? I'm gonna cut it in half. So I'm gonna do something right there. What's half of 2 pi? It's pi. So I'm gonna put pi right there. And then what's half of pi? Pi over 2, right? Now, so I got 1/2 pi, I got 1 pi, and then what goes in between 1 pi and 2 pi? 1.5 pi, or the improper fraction would be 3/2. So 3/2 pi. Right? So these are my 4 spaces, right? That's my horizontal. That's my horizontal setup, right? But now I need to worry about my vertical setup on my y-axis. So what I do is I go back to my amplitude. But before I even think about the amplitude, I need to think about what the midline or the center line of the graph is going to be. Now, since D is 0, D represents the vertical shift, right? Customarily, the midline of any trig function would be the x-axis, right? Or put this in your notes. Midline is y equals 0. The line y equals 0 is the x-axis. All right? It is the x-axis. Okay, that's usually what it is. Unless you have a number here representing D. In that case, if it was positive, then basically it would be shifted up that many units. All right, the midline. So in this case, the midline is the x-axis. So if the midline is the x-axis, now we go to the amplitude. The amplitude tells us how high the graph is going to go. So I do, let me see, 1, 2, 3, 4. And I'm going to say 4 units, because my A is 4. All right? And I'm going to do the same thing down here. Except now down here I got -4. So I got +4 and -4. So that means this is as high as the graph is going to get. This is as low as the graph is going to get. This is as high. This is as low. That's what the amplitude tells us. The amplitude tells us how far the graph is from the midline. And typically, when D is 0, the midline is the x-axis. All right? Now also, in some of these problems, when you have a number here for C, right, it gets a little even more complicated because then the graph gets shifted to the right or shifted to the left. All right, a whole lot of stuff be going on. All right, so now, this is my center line. And that should be like, one of your first steps. Identify what your center line is. But your center line in this case is the x-axis. So it's y equals 0, right? We want to plot the amplitude, okay? +4, -4, right? This high, this low, all right? Then we know the period. Period is 2 pi because we did 2 pi divided by b. What was b? B was 1. How do I know b was 1? I know b was 1 because that was the coefficient of theta, okay? So C was 0 and D was 0, so we don't worry about those. We don't worry about a vertical shift. We don't worry about a horizontal shift, okay? Next thing, this is a sine function, all right? Now, sine functions start at the center line. Sine functions start at the center line. Cosine functions come from the top, all right? So when I say start at the center line, you start at the y-axis at the center line. So what you want to do is you want to plot some points. And let me switch my color up so you can see this a little better. You want to plot some points. And then you want to play connect the dots. And then we'll be finished. So at the y-axis, right? Since the sine function starts at the center line, this is the center line. So I'm not going to put a point up here at 4. If this was cosine, that's what I would do. I'm not going to put a point down here at -4. If this was negative cosine, that's what I would do. But this is a positive sine. This is +4. So I put my first point right there, right? And then because it's positive, my wave is going up first, right? My wave is going to go up first. Not down, it's going to go up. So then right here at pi over 2, I imagine it goes all the way up to the top. I put another point. So my first point is on the y-axis. My next point, the x value is pi over 2, and it corresponds to the amplitude, to the highest point, right? Then at pi, it comes back down to the center line. So at pi, it's coming right back down here. All right? Then it keeps going down, but it keeps going down because remember, it's a wave, so it's going to go like this. It's going to go up. Boom, what goes up must come down. Boom, it's going to come down. At 3/2 pi, it's going to line up with -4, the lowest point, right? And then it's going to start to go back up again. And when it comes back up, it's going to be back to the center line again at 2 pi. So this is one period or one cycle. One period or one cycle. So the period is like, it's like one cycle. All right? Now, last part, we draw our actual graph. Start here, go up, come down, and go right back up. Boom. All right? And that's what our graph will look like. But this is only one cycle. Some graphs you may see will continue on. We could continue on. We can keep going. We can keep going. But it's going to do the same thing forever and ever. Okay? All right? So that's the graph of number one. Number one, y is equal to 4 sine of theta. It looks like this. So basically, what your steps are. What are your steps? Your first step is to identify your amplitude, which is A. Identify letter B. Also, the general, let me stop right there. The general equation for a cosine function, all you would do is replace the sine with the cosine. All right? Now, amplitude is A, B, identify whatever that is. Use B to find the period. Use B to find the period. All right? That's how long one cycle is. Okay? Identify C, identify D. And all these problems, C is 0 and D is 0. Then when you go to graph, identify what your midline is. Your midline is usually going to be the x-axis unless there's a vertical shift, which will push it up or push it down. All right? And none of these problems have a vertical shift. Okay? So, then you want to identify your cycle, plot your horizontal point so you'll know how wide it's going to be. Then plot your amplitude, your positive amplitude and your negative amplitude, so you know how tall, how high, and how low it gets. All right? Now, let's do the same thing with number 2. Y equals 1/2 sine of theta. I hate to erase these graphs, but I got to. All right. Yeah, let's do that. Hate to do it. All right, so now, erase that, erase that, erase this, erase this, erase this. My midline is still going to be y equals 0 or the x-axis, so I'm going to leave that up there. All right, now, going to this problem, number 2, A is 1/2. So that's my amplitude. So I'm going to write that down. 1/2. B is the coefficient of theta, which is 1. So 2 pi over B, just like the last problem. 2 pi divided by 1, which is 2 pi. All right, C again is 0 and D is 0. All right, so now I go to draw my graph. Boom, that's my y-axis. Boom, that's my x-axis. Now, my period, that is 2 pi. All right, half of that is about right there. That would be pi. Half of that would be pi over 2. Halfway between pi and 2 pi is going to be 3/2 pi. Now, this is not always going to be the case. If there was a different number inside, actually, no. What I mean to say is, if there was a different number in front of the angle, then pi would be different from 2 pi. Or the period, I should say, would not be 2 pi. It would be a different value. And then our graph will look different subsequently. Now, what is our amplitude? It's 1/2. So now I'm going to do this. I'm going to say, I'm going to go by 1/2 units. All right? So I'm going to make that positive 1, make that negative 1. Where's 1/2 at? 1/2 is right here. Where's negative 1/2 at? Right there. And you can make any scale you want on your y-axis or your x-axis. Actually, you can make each space worth 1. You can make each space worth 10, worth 1/2, worth 1/4, whatever you need to do. All right? So now, again, sine starts at the center. Sine starts at center. Cosine starts at top. I need to think of something more catchy to say to memorize that, though. All right, for people to memorize that, rather. Cosine starts at the top. So anyway, we're not on cosine yet. We're on sine. We're still on sine. So sine, right, starts at the center. So that means I'm gonna start. Let me switch my color up. I'm gonna start at the x-axis. So I'm gonna start at the x-axis at 0. Right? My y value is 0. So I'm gonna draw that point. I like to draw my points first. Some people draw the wave, go straight to the wave. I like to draw the points and then draw the wave. All right. And this number, this 1/2 is positive, so that means I'm going up first. All right. Now, my amplitude is only 1/2. So that's as high as I go, right? So then when I line up with this x value, I'm gonna be at 1/2. So I'm gonna go up first. And then when I line up with this x value of pi, I'm gonna be back at the center line. So I'm gonna be right here. And then when I line up with this x value, I'm gonna be down here at the lowest point, which is -1/2. So that point's right there. And then when I line up with 2 pi, I'm gonna be back up at the center line. All right, so I got my 4 points. So now I just draw my graph. Up, down some more, and back up. All right? Now notice, because in this case, A, or the amplitude, is less than 1, right? It's greater than 0, but less than 1. This represents what's called a vertical shrink. It's shrunk down, right? Smashed, all right? This is a vertical stretch because it's greater than 1. That's why I seem taller, right? Taller than what you might be saying. But typically, because the amplitude is usually 1, if there's no number written here, then the amplitude is understood to be 1. So compared to number 1 up here, with the amplitude being 4, that makes it taller, right? Because 4 is bigger than 1. So that means your graph is going to be higher than what it would be if you only went to 1. All right? So this is your graph for number 2. Now, number 3, we're actually looking at cosine. We're going to look at cosine for number 3. All right? But we do everything else the same, basically. Everything else is the same. Everything was the same, except for the fact that we are dealing with cosine. All right. I'm going to erase that because I'm going to have a new amplitude. I'm going to erase that, even though I think that's going to be the same. C equals 0. All right. So now, let's look at number 3. Let's identify our amplitude. Our amplitude is the coefficient of the trig function. In this case, it is 3. So I'm going to write 3, or A equals 3. B will be the coefficient of theta, which will give us 1. So then 2 pi divided by 1 is just 2 pi. So that's how wide one cycle is, 2 pi units. There's no C term inside the parentheses. There's no D term, right? So we got 0 and 0, right? So now we go to draw the graph. Now it's time to graph. That's your y-axis. Boom, label that. This your x-axis. Label that. All right, now, my y values. I know that my amplitude is 3. So I'm going to have 3 positive units and 3 negative units. So I'm going to go 1, 2, 3. 1, 2, 3. -1, -2, -3. Right? Now, period. 2 pi. Right? 2 pi right here. Half of that is pi. Half of that, pi over 2, or 1/2 pi. So we got 1/2 pi, 2/2 pi. And you know that pi is equal to 2/2 pi, right? And then that's why we know that this is going to be 3/2 pi. And then 4/2 pi. 4/2 pi is the same thing as 2. Because 4/2 is 4 divided by 2. And 4 divided by 2 is 2. Another way to look at it. All right, now, cosine is different from sine because with cosine, your graph starts at the top as long as A is a positive value. If A were a negative value, it would be like a reflection. You would start at the bottom, right? The lowest point. So with cosine, positive cosine, you start at your highest point, like a roller coaster, right? You start at the top and then you drop, all right? So on the y-axis, we're going to start at the highest point of the graph, which in this case is +3. So with cosine, we start at the top. So I draw the point right there. and then we drop down, we line up with pi over 2 on the x-axis. So we drop down, and then we keep dropping to the lowest point. Pi lines up with -3, the lowest point, right? So we start up here, we drop down, we line up with pi over 2, and we keep going down to the lowest point, and then we come back up. Then we come back up because that's the lowest point. We can't keep going down if that's the lowest point. We already hit rock bottom. Think of that as rock bottom. Then you start to come back up. You come back up, you hit the midline, or in this case, y equals 0, or the x-axis. So that's your next point. And then we line up with, and then we keep going. When we line up with 2 pi, we're back up to the highest point, which is 3. So we start here, we come down, drop right there, and we come back up, and then we just repeat the same thing. It would just go back down, and then go and keep going like that. And it would just keep going like this, like forever and ever and ever and ever and ever. And it would go in this direction too if we wanted to. We wanted to show that. All right. So like I said, this is just like, these are some fundamental problems. This is like some quick and dirty sketches of how to show the graphs of trig functions. And I hope that this made sense. And remember, all we have to do is just look at the equations. Don't let them intimidate us, right? Pick out the important information, because all the information you need to graph this is embedded within the equation. You just have to know what goes where. So you know that this is A, and that tells you your amplitude. That tells you how high the graph is. So like in number 3, our amplitude was 3. So that's how high the graph is and how low the graph is, right? And what the midline is. If there's no vertical shift or D value or plus any number, then there's no vertical shift. So the midline is the x-axis, or y equals 0. All right? But yeah, you just got to do a bunch of these problems over and over again. That's the key. That's the key to these. Just do a bunch of them over and over again. Make the mistakes. The mistakes can be helpful. Make the mistakes, go back, correct them. All right? And do sine functions, do cosine functions, do some where the amplitude is negative, do some where you have a horizontal shift, do some where you have a vertical shift. We'll do a future video. We'll do a future video with some more complex examples of graphing trig functions. Don't worry. We'll do some more videos. We got time, right? We got nothing but time, right? Yeah, so that's about it. So thanks for tuning in. I hope you learned something. Continue to send in your problems to the All This Math DM, and you might make it to the board. Peace.